how can the sun's outer atmosphere be hotter than its surface? This elusive pearly white cloud is made from a state of matter rarely found on Earth, called plasma. If you heat a gas to a high enough temperature, some of the electrons in its atoms fly off, leaving positively charged ions. This superhot mixture of ions and electrons is known as a plasma. Although rare on Earth, plasma is the most common state of matter in the universe. Most stars we can see are made from it, including our sun. 1.3 million times larger than the Earth, our sun is a dense ball of plasma made from hydrogen, helium, and smaller amounts of other elements. The heat that creates this plasma is generated inside the sun, at the sun's core. Here, the extreme pressure of gravity forces the hydrogen atoms to fuse together, creating helium and releasing vast amounts of energy as photons of light. This nuclear fusion heats the core to 27 million degrees Fahrenheit. From here, the photons of light pass through the dense inner layer of the sun. The temperature of the plasma gradually drops as the photons reach the sun's visible surface, known as the photosphere. Here, rising and sinking plasma forms a seething surface of light and dark areas. Around the photosphere is the corona, the sun's outer atmosphere of extremely diffuse plasma extending far into space. Nanoflares are thought to be explosions on the sun. According to the theory, the trigger for nanoflares comes from the sun's magnetic fields.
So these fields are much, in fact, like rubber bands. They can be stretched and twisted and stressed.
The arches of plasma that rise from the sun's surface can be made up of many magnetic field lines. As the sun's plasma churns at the surface, it can twist and tangle these magnetic field lines, creating stresses that build up until eventually the lines break and reconnect in a simpler configuration. This releases huge amounts of energy in a nanoflare. Millions of nanoflares are thought to be going off each second, beginning at the sun's surface and reaching into the corona to heat it to over 1 million degrees.
Each nanoflare is the equivalent of a 50 megaton hydrogen bomb. They're happening at a tremendous rate, 1 million or so per second across the sun. So collectively, they really pack a wallop.